Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Hello and welcome. I'm your host, Peter Ballant from Technicon, and today we will look at the EPIC project once again. EPIC is a European effort with 8 partners from 7 different countries. Partners include SMEs, industrial concerns, research institutions, and universities. Like many other current technology projects, EPIC is here to ensure that the things that work great now will also work in the future. In the case of EPIC, the focus is on forward error correction. Today we speak with Jhon Jimenez and Timo Lehnigk-Emden, both from Creonic in Germany. Creonic designs and delivers complex signal processing functions for communication systems. We'll start with Jhon. Can you break things down for us a bit? Who needs forward error correction?
Well, actually, we all need forward error correction, even though we don't notice it. What that means is whenever we're transmitting data over any sort of digital communication, that data has to go to travel through a medium, and more often than not, this is a noisy medium, and data gets distorted. What forward error correction does is it adds some redundancy to this information, so it could be corrected at the other end without needing to retransmit the information, or without needing to retransmit more often the information. That's basically what it's all about. So if you're using a smartphone, if you're using internet, there's forward error correction in the background working for you, making your communication as reliable as possible.
Yes, right. Every kind of digital transmission uses forward error correction. This means every time you transmit any digital data, error correction is an essential part of it.
So it sounds like this is something that it's a process that has to be there, although nobody really sees it. It's just the end result is that people get their data, people get their voice coming across a telephone in an error-free fashion. Is that right, Jhon?
Yeah, absolutely. I mean, it's not completely error-free. I mean, some errors come here and there. That's unavoidable because of the nature of things. But the goal is to make it as reliable as possible. And it's just a transparent process that happens without us noticing it.
So without error correction, we wouldn't be able to communicate, essentially. Timo?
Yes, right.
Or things would take a lot longer anyways.
Let's say, or you can thought about this like old analog telephone wire. These had no error correction, of course, but everything which is done in the digital world must be protected by forward error correction.
How long has forward error correction been in use?
I would say as long as digital communications have been around. The theory behind it dates back to 1948, actually, from a couple of scientific papers by Claude Shannon and Alan Turing, which are respectively part of information theory and in computer science. And these theories have been around from the 40s, and now that the digital communication era has arrived, people notice that this is actually something useful for this kind of application, and they've been applying it to it. So giving a precise date on the arrival of forward error correction is a little bit difficult to answer.
Okay. But the situation now is that we're moving into this era where we have super high speed communication and data transfer rates. And the forward error correction codes that we've been using in the past just simply won't work. Is that right, Jhon?
Well, yes, no. It's not that they won't work. It's just that the last couple of decades, we've been relying on technology scaling to make things faster. What that means is that we're relying on the actual chips and transistors getting smaller to get things faster, but we've actually never gone into the architecture and algorithms themselves in a way that we can refine them, that we can make them more efficient about it. And that's the actual goal of EPIC, to make them optimize this architectural and algorithmic approaches so that we could take more advantage of the technology that we have and also leverage more throughput and benefits from this technology.
Jhon, you're a project partner in EPIC. Can you tell us specifically what your role is in EPIC?
Well, we are a SME in the project. Our core market is actually intellectual property for digital communication. So this seemed like a very appropriate project for us. And in EPIC, we're actually investigating one of the types of codes that we described called LDPC codes. More specifically, a somewhat new algorithm called spatially coupled LDPC codes, and that's something that we wanted to investigate in this project. Also, we've made some FPGA demonstrations in a couple of conferences, showcasing the results of the project. So, for instance, last year we had a presentation in EUCNC in Valencia, Spain, where we showcased some of the results that we had in the project. So that's basically our one of the tasks that we have around here in the project.
So Timo, tell me your specific role in the EPIC project.
I'm the technical manager of this project.
Okay, and this is a project that has many partners from many different European countries. And is it your job to sort of pull them all together and make sure they're working in the same direction?
No, that's a part of the technical lead. My job is to manage the project within Creonic.
I see. Okay.
To make sure that we have all resources, that the people work in the right direction, that the communication with all the partners works fine, and if we have problems in administrative stuff or technical stuff.
I see. Based on what you're telling me, it sounds like Creonic is able to bring a lot to the table then when it comes to EPIC in terms of technology experience, and this is what you do actually. So
yes, that's what we hope for.
Okay. I wanted to ask you also, in these types of projects, many times there are use cases, and these use cases are sort of real life situations where this technology might be used. And many times these use cases help the average person to understand a little bit more about the project. Do you have such use cases in EPIC, Jhon?
Yeah, we have identified a couple of use cases for this project, and they actually can be classified in terms of infrastructure and consumer electronics. I guess the average user would be more familiar with the latter, specifically something that we found to be pretty new would be these VR headsets that are coming about in later years.
And I should mention VR is virtual reality.
Exactly. These new things of augmented reality, virtual reality. The video input that you need is actually so demanding because you have to render constantly, sometimes unexpectedly, because the user is constantly moving and changing the environment. So this is a very computationally heavy and data heavy application. And what that means is that it would need a lot of throughput. A lot of information would need to be transferred very fast for this kind of application. So VR sounds like one of the ideal use cases for this project. Also, if as throughput gets considerably higher, that would mean that several buses in your personal computer would benefit from this as well, and even smartphones. And from the infrastructure perspective, that would mean the cellular network will also get faster. We're hearing a lot about 5G in later days, and what that means is that connectivity will get improved, so you could more people can get a reliable service in larger areas, and you can actually download and upload information much faster than we used to. So in order to support that, the network has to have a very robust backbone in order to transmit all of this huge amounts of information. So that's something that we also identified as being a potential candidate for a EPIC use case.
The use case which is most interesting for Creonic is this HTS, this high throughput satellite stuff, because we see there actually a large demand in increasing the network capacity of a satellite. And satellite communication is a very essential part to establish transmissions and links around the globe. And everybody wants to increase the data rate on the client side, and the satellite network, which are already launched and which will become larger and larger in the next years, will play a major role in reaching this goal of a global high-speed network, which is available everywhere and every time.
Okay. And you often refer to beyond 5G speeds. In fact, you are working on forward error correction for beyond 5G speeds. What does this mean in terms of time? I mean, when is it that we will see the fruits of your labor in day-to-day life?
Well, it's hard to tell precisely when. I mean, 5G, it's currently being deployed. It passed already the standardization period. And as you can see, the 5G networks are being slowly but steadily deployed, at least in Europe. And but currently, I mean, from the discussions and material that's being presented in recent conferences, although 5G hasn't been completely deployed yet, people are already talking about what's next. So people are talking about 5G, 6G, or even 7G, which is basically beyond 5G. So I wouldn't be surprised if some standardization efforts are currently being done for 6G and 7G. So let's say couple of years, 5 years, I would expect the deployment of these new beyond 5G technologies, or at least that's my guess as to the matter.
Okay, but there's nothing really solid. I mean, it just sort of depends on the way technology moves. Is that right?
Yeah, basically. But taking into account the current trends, I wouldn't be surprised if beyond 5G gets deployed in a couple of years.
Okay. And I was just looking on the website for the EPIC project, and I see that the project is actually done.
Yes.
And okay, so how are things? I mean, how do you feel? You know, could you say at this point that this was a successful project, or we still have a lot more work to do, or is it too early to really say much?
Well, there's always going to be work to do, and that's actually a good thing. We want things to continue and to be continuously improved. But I think we are actually very satisfied with the results that we've had. We only had a minor step back in the last couple of months because of the current situation with the pandemic. But other than that, I think we're very satisfied with our results, and we hope that we can actually improve upon them in future projects or future endeavors.
Timo?
I feel very good because we had a lot of interesting problems to solve, and we gained a lot of experiences and new knowledge. And I think also that the people have been worked really, really hard on this project, and they really enjoyed the difference to all-day business in sense of communicate with other companies and other research institutes.
And how does this work in a project like this? I mean, your team has put forth quite a bit of effort to accomplish the goals of EPIC. When EPIC goes away, then, do you continue with these efforts, or are they funneled somewhere else, or is there a possibility for a second EPIC project along the way?
I couldn't tell yet, but we're actually in some discussions about whether or not we continue. Some of the partners continue in separate projects. Some of these partners are academic institutions, a couple of universities. So of course they would like to continue. From our perspective as an SME, we would also be glad to continue in a project like that, or maybe a different endeavor, maybe leveraging a couple of IP products to the market. So, of course, we would like to work upon the work that's been done in EPIC so far. There have been some discussions, as I said, in continuing upon this work, but I wouldn't be able to tell for sure how that would shape out.
I see. Timo, let me get your assessment. Could you propose a second project at some point after EPIC is done?
Yes, that's of course possible. In general, we try to keep in contact with the partners, to contact them if we have some special problems which are related to their special knowledge.
Okay. Yeah, I guess we'll see down the road. I wanted to ask you too, Jhon, a project like this, which consists of 8 partners from 7 different countries, surely faces some challenges or roadblocks. Can you point to anything specific, and how did you overcome these challenges?
Well, yes. Mostly that's, I would say that goes down to coordination, where sometimes it's hard to coordinate some efforts between all of us being in different countries. But that's just a minor roadblock, and actually I wouldn't consider it to be such a big deal. I would say Technikon, for instance, has done a very good job in coordinating the project. The roadblocks that we've had, for instance, would be accessing to some specific technology resources that we would very much like to use for our research, but we couldn't because of logistics or legal reasons. But other than that, I think we've had big challenges, or threatening challenges, I would say. We don't have something like that.
Okay, so everything seemed to move along as scheduled. Yeah, that's great.
Yes.
Okay, is there anything you would like to add about EPIC?
Well, I think, as I said, it's been a very successful project. All of the partners are also very satisfied with our results. We're all very happy with the outcomes that we've gotten. And we're hoping to work again in a similar or maybe a continuation of the project if things shape out accordingly.
This is an important project. Even though people can't see it or touch it, it's important that you're doing this work. So thank you for your efforts there. And thanks for pushing this project through and giving us what we need to continue on in the next generation of communications. And thanks for talking to us about it today on this podcast.
Thanks, Peter.
Well, thank you for having us as well.
For more information about the EPIC project, check out their website, epic-h2020.eu. This podcast has been brought to you by Technikon. The EPIC project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 760150.